Hey everyone, Mr. Galton here, back at it again, lesson 6 in the unit that we are in. I believe it's unit 10, and we're talking today about simplifying rational expressions and being able to multiply and divide rational expressions. So we're kind of getting away a little bit from our concept of direct and inverse variation. So really the first lessons 1 through 5, we're really focused on direct and inverse variation and graphing and shifts and things like that. And now we're going to kind of change gears a little bit and get to more of these rational expressions. So just real quick, remember that rational is just a big fancy word for a fraction. So we're going to be dealing with fractions, okay? The other thing that you're going to be asked to kind of recall is the other F word in math that most people hate, factoring. We're going to have to factor like crazy. We're going to have to do the box method. Right? If you remember factoring using the box method, when we're talking about factoring, we're going to see quadratics again. All right? So anything with x squared in it, where we're factoring those. Other things that you're going to have to recall: perfect squares, like factoring like x squared minus 4. Those are that's called the difference of squares, because that factors into like x plus 2 and x minus 2. So a lot of the algebra 1 concepts are kind of coming back. We covered these in first semester, but that's the kind of the world we're getting back into. So let's just jump right into it and start doing some problems, and hopefully it kind of jogs your memory. So simplifying, again, another way we can say this, since we're talking about fractions, rational fractions, is reducing. We want to reduce these fractions as far as we can go, and that's going to be the idea. Now, you see restrictions. We'll talk about this in a minute, but the restrictions essentially just means this, the denominator, okay? And we'll talk about that when we get to our answer. So let's take a look at the first one. We have negative 27x to the third over 9x to the fourth y. Well, remember, there's time signs in between all of these, and as long as there's multiplication symbols in between them, we can simplify and or reduce. So like 9 goes into 9 once, into 27 3 times. So right now I have basically negative 3 over 1, even though we don't need to put that 1 there. We have x to the third and x to the fourth on the bottom. So if we were to slash out x's, 3 x's on the top would slash out with 3 x's on the bottom, which would leave you with 1 x on the bottom left over. And then there's no y's on the top, there's just 1 left on the bottom. So our final answer, if you really wanted to get specific, would look something like this, negative 3 over xy. Now, what's the restrictions? You're going to have some questions that ask you, what are the restrictions? And what you do with restrictions is you focus on the denominator and what the denominator can't be. We can't have 0 be in the denominator, right? Anything divided by 0, any number divided by 0 is not possible. It's just you can't do it. And so basically what we would say here for restrictions are that x and y cannot equal 0. Because if x was 0, we'd have 0 times y, and anything times 0 would be 0. So we cannot have the denominator be 0. That's what restrictions mean. So the restrictions is a focus on the denominator. Okay, looking at number 2. So here's where we get into more of the quadratic factoring. So you take a look at this. When you have a coefficient in the top, I do the box method. I know some teachers don't do that. They do guess and check. Whatever method you learned in Algebra 1, or if you remember, if you had like Mr. Panning or another teacher for Algebra 2 and you learned it a different way, that's fine too if you did guess and check. I always put the first term in the first box, the last term, including the symbol in the last box. I multiply the two numbers together, which would make negative 4, and I basically cross out this last term and I replace it with the number 2 times negative 2 is negative 4. And then I ask myself that very popular question when factoring: what two numbers multiply together give you negative 4, but those same two numbers add together to get negative 3, which would be negative 4 and positive 1. And just double check. Negative 4 times 1 is negative 4, check. Negative 4 plus 1 is negative 3, check. We add a variable to those two boxes. The only box that does not get a variable is the last box. And then what we do from there is we find GCFs, greatest common factors. So I draw an arrow across this way and I say, okay, what's the greatest common factor of these two boxes? 2 and x, so 2x. What's the greatest common factor going across those two boxes on the bottom? Just a plain 1. And then we go up. GCF of those two boxes would be just x, and going up this one would be a -2. Now you may be wondering, okay, Mr. Skelton, well, how is that a -2? The only time you pull out a negative factor is if this box here or this box here is negative. And so the only two factors that can be negative is this one and this one. You will never have negative factors be their first ones. So how does this top expression factor? It factors into 2x plus 1, which is here, and x minus 2. And you can write those in any order. You could have put the x minus 2 first. On the bottom, since this does not have a coefficient in front of x squared, you can just factor this by asking yourself that question. What two numbers multiply together give you +6, add together you get -5. Okay, so that's going to be x minus 3 and x minus 2. Check it. -3 times -2 is +6, check. -3 plus -2 is -5, check. Perfect. So when we do these, the first thing we want to do is we want to factor. The second thing we want to do is we want to reduce or simplify. Now, again, remember that there is technically a time sign in between these. So anything that is the same reduces out. So what you look for is something that's on the top that's exactly the same thing as something on the bottom. As long as you have the parentheses, and as long as it's multiplication, these x minus 2's reduce out. And so what you're left with is 2x plus 1 over x minus 3. Now, what you cannot do is take this x and take it out of this x, because you have x minus 3. It's not multiplication like we did here. Notice this is multiplication. There's no addition or plus sign, or excuse me, plus or subtraction signs in between. So we cannot take these x's out here. This problem is as simplified as it can be. That would be our answer. Now, restrictions. Remember, restrictions deals with the denominator. What number can't x be so that you would get a 0 in the denominator? X could not be +3, because if x was +3, 3 minus 3 would give you 0, and anything divided by 0 is undefined or not possible. All right, let's keep moving there. So here we have a situation where it, just kind of a little word application problem. It says simplifying rational expressions, so we're doing the exact same thing conceptually. What is the ratio of the volume of this cylinder to the surface area of this cylinder? So what is the ratio? Ratio means what? It means fraction. So you're creating a fraction of the volume to. Whenever you see the word to, that means the volume is going to go on the top of the fraction. To the surface area, that means that's going to go on the bottom of the fraction. You can kind of see I have that set up here. So volume is going to be pi r, I believe volume is pi r cubed h, not pi r squared, over 2 pi r squared plus 2 pi r h. Okay? And so what we need to do now is simplify that. Well, what should we look to do? What we should look to do, or what you should recognize in the bottom, is that you have a plus sign, so this is a quantity, and you want to look to see if you can pull out a GCF out of anything in the bottom, which you can. So I'll just rewrite the top, pi r cubed h over. What can I take out of this and this that is the same? I can take out 2 pi r. So I'm going to take out 2 pi r, and then what's left? What would be left would be just r in this one plus h here. Okay? And then, so what can I cross out? I can cross out this pi with this pi. I can take this r with one of these, so I'm just left with 2. So I end up having just r squared h over 2 times r plus h. Okay? And I can't take anything else out. You don't have to distribute the 2 back through. You want to leave things in factored form. Leave in factored form. Okay, some students will run this 2 back through. We don't have to do that. We want to leave it in factored form. And so that is our answer right there. Okay. Moving on. So now we are multiplying the following rational expressions. So again, when you look at this, the first thing that should be going through your head is, how can I factor? So I basically look at the top, look at the bottom, and I ask myself, and I just go one at a time. Can I factor this top? Can I factor this bottom? Can I factor this top? Can I factor anything out of this bottom? Get everything factored first, and then start crossing stuff out. So on the top here, this is a plus 2, a minus 2. This factors into a plus 1 and a minus 1. This a plus 1 really doesn't factor, it's just a plus 1. And then I can take out, it looks like I can take out an a here, and I'm left with a plus 2. Okay? So I have factored everything that I could factor. Now, what is this? What do we do from here? Well, yeah, there's a multiplication sign, but the last thing you want to do is multiply these together. Now, I will have some students who will just kind of push everything together, but I'm going to give you an example of something that you can hopefully relate to this problem to make it easier for you. So let's just take a fraction like 2/3 times 12, we'll go 12/5. Right? So when you multiply fractions back in elementary school, how were you taught to multiply fractions? Straight across, right? So 2 times 12, 3 times 15. But you could simplify your fractions first by doing what? You're probably taught to cross simplify, not cross multiply. Don't cross multiply. What I mean by cross simplify is this. See how 3 is here and 12 is here? They have a common factor, which is 3. So we could go, oh, 3 goes into 3 once, 3 goes into 12 4 times, and now we get 2 times 4, which is 8, over 1 times 5, which is 5, and we get 8/5. What's the purpose of cross-reducing? Well, the purpose of cross-reducing is to simplify before you get to the very end. If we did not cross-simplify here, I'd have 24 on top, 2 times 12, over 3 times 5, which is 15, and then you'd have to simplify your final answer into 8/5. The whole point of what I just showed you here to apply to this problem here is the idea of cross-simplification. Let me show you. Here I have a fraction, albeit the 2/3, acting like the 2/3, and this would be like your 12/5. Is there anything on this denominator that's the same as anything in this numerator, i.e., we took out a 3 here and we took out a 3 here, it's the same? I do. I have a plus 1 and a plus 1. As long as you have something on the top that's exactly to something on the bottom, it doesn't matter the location of where it is on the top or the bottom, they can be crossed out. This a plus 2 can be crossed out with this a plus 2. We have nothing else that can reduce, and so our final answer just becomes a minus 2, which is left on the top here, over, we usually put this single a out in front, and then a minus 1. Again, we do not want to run this a back through or distribute it back through. We want to leave things in factored form. This would be our answer. Now, what are a lot of students going to do wrong? They're going to cross out these a's here, right? They're going to have some, you could get an answer like this, a minus 2, a minus 1, and I'm going to have kids go, oh, I'm going to cross out those a's, and I just get positive 2 as an answer. Please don't do that. You can't do that. Now, if it was 2 times a over, 4a, yeah, you could cross out the a's and you could reduce the 2's and get 2. That's different because I have multiplication in between these things. Here I have subtraction signs. When it's a quantity of subtraction or addition, you can't cross out those a's. Okay? Restrictions. What can't a be? A can't be positive 1 because 1 minus 1 would be 0, and a cannot also be 0 because if I plugged a 0 in just for that a, I'd have 0 times whatever this is, and that would not work. So there's actually 2 restrictions on that problem. Moving on, almost done here. Now, division. If you remember your division rules of fractions, if I had 2/3 divided by, 4/5. Some of you in middle school, I hate even saying this, but keep it, change it, flip it, right, is something you maybe learned. But the general rule is when you divide fractions, you change the sign from division to multiplication. So there's my division sign, I changed to multiplication, and you flip or make this the reciprocal of the second one, right? And then you would go ahead and multiply straight across and get something like 10/12, and then you would reduce that down, or you could cross simplify there. That concept is carried over exactly right here. So you can do this one of two ways. You can factor the top, factor the bottom, factor the top, factor the bottom, or a lot of students will change this to multiplication and rewrite this as 3a minus 12 over a plus 5. I like to flip the second fraction right away so that I don't confuse myself and start cross-reducing when I shouldn't. So now I'm going to go ahead and factor this top. Two numbers that multiply together that give you negative 15, add together you get positive 2. That should be a positive 5. and a negative 3. Right? 5 times negative 3, negative 15, check. 5 minus 3, positive 2, check. The bottom factors into a plus 4, a minus 4, that's difference of squares, times, take out a 3, left with a minus 4, and then a plus 5 can't reduce. So now once I get it to this point in time, I'm looking for anything on the top that's the same as anything on the bottom, and I'm going to reduce those out. Here's an a minus 4. There's an a minus 4 on the bottom. Gone. Here's an a plus 5. Here's an a plus 5. Gone. I don't have anything else that can reduce. This 3 is just hanging out, so I'm going to put that first. I have a minus 3 also in the numerator. That's going to go next. On the bottom, I just have a plus 4, and that's all I have. I cannot cross out these a's. Do not distribute the 3 through. Leave it in factored form. That is my answer, my restriction. What can't a be? A cannot be negative 4 because negative 4 plus 4 would make 0, and we can't have 0 in the denominator. Bada boom, bada bing, we are done. Okay? So you can see a lot of the Algebra 1 skills kind of carrying over into this lesson as we kind of move towards the finish line in this unit. These last few lessons will be focused more on these type of problems where you're doing some factoring of rational expressions and simplifying of rational expressions. Okay? As always, if you have questions, look forward to seeing you in class and helping you out. Take care.